What if everything we thought we knew about space, time, even gravity was just, one piece of a much bigger picture?
Much more incredible puzzle, perhaps.
Exactly. Welcome to the deep dive. Today we're plunging into a really thought-provoking theory from a contemporary thinker, Ali Yusuf. It's called Ali Yusuf's theory for explaining the behavior and composition of the universe.
That's right. And our mission here, really, is to explore his unique ideas. They offer a pretty bold challenge to some of our, let's say, conventional physics.
Yeah, definitely bold.
We're going to use his own sources as our guide, looking into concepts like, well, faster than light speeds, unseen dimensions, even the origin of existence itself.
And just to make it concrete for you listening, we're focusing on how Ali Yusuf tackles three huge questions. First, can anything move faster than the speed of light? Second, are there real dimensions beyond the four we all experience? Length, width, height, time, anything else.
Right, the biggies.
And third, what's the ultimate origin and source of the universe? So this deep dive is basically your shortcut to getting your head around some unique insights into how the universe might work, and maybe the philosophical side too, helping you get, well-informed quickly.
Let's unpack it then. Ali Yusuf is proposing this really comprehensive model for the cosmos. You can think of it maybe like how Einstein started with propositions for relativity.
Okay, like foundational ideas.
Exactly. Or how the standard model in particle physics is built on hypotheses. His theory aims to go from these initial ideas, these propositions, all the way to, hopefully, verifiable scientific experiments and equations. It's incredibly ambitious.
It sounds it. And the core of this vision, the really big claim, is that the universe has other dimensions beyond our usual four.
Yes. And he gets specific. He talks about two-dimensional spaces. So length and width exist, but time is, and this is his phrasing, reserved within or integrated into these two dimensions.
Integrated into, okay, that's different. What does that actually mean for time? Not just a fourth track we move along.
Precisely. That's the revolutionary part.
Yeah.
It redefines time. It's not this separate line, but an intrinsic property of that 2D space.
Huh. Like texture on a road, maybe?
Kind of, yeah. It affects how you perceive things, how causality might work differently within that space. It's not moving through time. Time is part of the spatial fabric itself in those conventions.
Wow. Okay. And the implication of that?
Well, this is where it gets really interesting for potential applications. Yusuf suggests this shift, this different structure, could allow humans to travel way faster than light.
Making interstellar travel actually possible.
That's the idea. Not just science fiction, but potentially achievable, because the rules are different in these other dimensions.
Okay, now this is where things take a, let's say, unconventional turn in terms of evidence, right? He doesn't just stick to theoretical physics.
No, he brings in something quite different. He uses what he calls a foundational axiom, or postulate, that comes from a religious event.
Yeah.
The Prophet Muhammad's Isra and Miraj, the night journey and ascension.
Right. So he's looking at the descriptions of that journey and pulling out physical principles. How does he actually do that?
Yes, he treats it as a key principle. The traditional story describes this journey covering, billions of light years in a very short time.
Which, yeah, straight away implies faster than light travel.
Immensely faster. But the detail that's crucial for Yusuf's theory is that the prophet reportedly felt nothing. No sensation of movement, no extreme speed, no biological effects you'd expect.
All right. No crushing G-forces or time dilation effects as we'd understand them.
Exactly. That lack of sensation is really key for him.
And it goes deeper too, right? Didn't the account mention seeing future events?
It did. Observing people in hell, which Yusuf interprets as seeing the future. So it wasn't just travel through space, but through time as well.
And he talked to prophets, angels. The sound worked normally.
Apparently so, yes. Suggesting normal laws of sound transmission, despite everything else being so extraordinary. It's a really unique way to approach it, framing a religious text as containing scientific data points almost.
So how does he connect this feeling nothing and the reported blindness when ascending to heaven with physics? How does outrunning light make you blind, in his view?
Well, he points to a specific Quranic verse, Al-Hijr 15, verses 14 and 15. It says, basically, if a gate to heaven opened and people ascended, they'd say, our eyes have been blinded. Rather, we are affected by magic.
Okay.
Yusuf interprets this as, in his words, a purely scientific verse. He argues it literally describes traveling faster than light. Your eyes are blinded because you've outrun the light photons.
You can't see if the light hasn't reached you yet. Makes a weird kind of sense.
Right. And the feeling nothing, the magic part, is because you're operating outside the familiar laws. Newton's laws, biological processes as we know them, they're superseded in this strange universe, as he calls it.
So this idea of a scientific miracle is central. It's not just poof, magic, but understanding the how, even if we can't replicate it.
Exactly. He makes a distinction. A scientific miracle is when you understand the whole mechanism, the how it works, but you lack the ability to actually do it, the why not.
Now, can you give an example?
His example is like a biologist. They can understand every single component of a fly, the cells, the systems, everything, the complete mechanism.
Right. They know how a fly works.
But they cannot take raw materials and just create a fly. That inability to apply the known mechanism, that's the miracle, he suggests. It implies, perhaps, that we're meant to understand, even if creation remains beyond us.
That redefinition definitely shapes his view of the universe. He talks about it being miraculously created with inherent dualities where opposites exist together. That seems counterintuitive to our logic.
It is, to everyday logic, but he argues it's fundamental. He gives examples like the wave-particle duality of light. Is it a wave or a particle? Well, it's kind of both.
Okay, yeah, physics accepts that one.
Then there's electron and positron matter and antimatter. Past, present, future may be existing concurrently, which ties into physics concepts like light cones, and then broader concepts, heaven and hell, life and death, good and evil, angels and jinn, the visible world versus the quantum world, and crucially the world of the unseen versus the world of the witnessed.
So the universe is built on these tensions, these paradoxes.
That's his perspective. Seemingly contradictory states are actually fundamental to reality.
And that brings us to the world of the unseen, the Keeb. That's usually a concept of faith. How does he connect it to, actual physical stuff for people who want proof?
He uses black holes as a kind of analogy, or perhaps more than an analogy. He links them to heaven and hell.
How so?
Well, the idea that once you cross the event horizon of a black hole, you can't escape. Like the concept of hell being inescapable.
Okay, I can see the parallel there. And heaven.
Heaven is often described as vast, as wide as the heavens and the earth. Yusuf suggests that inside a black hole, while you might be moving, time behaves so strangely.
Because it slows down infinitely at the event horizon, from our view.
Right. And from inside, he speculates time might effectively stop or become meaningless in our usual sense. So if velocity is distance over time and the change in time approaches zero,
then you could cover huge distances but feel like no time passed, maybe no movement.
that's the idea. It serves as a physical analogy for an infinite, timeless realm like heaven, where movement doesn't equate to experiencing time passing. It's a mind-bending concept.
Definitely. And he brings in other physics, too, right? Like superconductivity.
Yes, he proposes superconductivity as a phenomenon that might hint at how mass's effect in space could be essentially erased.
Erasing the effect of mass. What would that do?
Well, if a mass's gravitational effect is nullified, maybe that allows for faster than light travel. It could also be linked to transitioning into that 2D space he talks about, maybe even becoming invisible to our normal 4D perception.
And he even speculates about the nature of angels and humans.
He does. He suggests angels might be composed of bosons and humans or other creatures of fermions. These are two fundamental types of particles with different behaviors.
Right. Bosons can occupy the same state. Fermions can't.
Exactly. And there are known interactions where energy can be transferred between these types. He posits this could be a physical mechanism explaining how the angel Gabriel might have transferred power or enabled the prophet's mirage journey. He's constantly looking for potential physical explanations.
Trying to bridge the gap between the seemingly miraculous and the potentially physical.
That seems to be a core theme. And it extends to established physics principles, too, like Heisenberg's uncertainty principle.
How does he reinterpret that? I thought it was pretty settled.
Well, he offers another interpretation. Instead of focusing only on the uncertainty in position versus momentum linked to the size of the mass, he focuses on the effect of that mass on space itself. His idea is the less the effect of mass in space, the greater the distances a body can cover.
So less gravitational influence means more freedom to move.
Essentially. And taking it to the extreme, if a mass had no effect on space whatsoever, then the uncertainty in its position, delta x, could theoretically span the entire universe.
Meaning it could be anywhere, instantly.
That's the implication. If you nullify mass's distortion of space-time, the normal limits might just dissolve. You'd transcend our known physics. It's a direct challenge to how we usually think about mass and location.
And this links back to space-time geometry, Minkowski space, and Einstein.
Yes, Minkowski space is the baseline, this sort of flat, unchanging grid. But Einstein showed mass and energy bend it, creating gravity. Yusuf emphasizes the rigidity of space in our 4D world.
Meaning it's hard to bend.
Extremely hard. He mentions the factor GC2, which is a tiny, tiny number. It means you need absolutely enormous force or energy to make a significant dent in space-time, or, crucially, to travel faster than light within our reality.
Which is why we don't see things just zipping past light speed normally.
Exactly. Our 4D space is very resistant to that kind of change.
Okay, so building on that, he uses the light cone idea to talk about different types of space. Time-like and space-like.
Right. The light cone diagram is a standard tool in relativity. The time-like region inside the cone is our everyday reality. Events happen, then we perceive them. Cause and effect follow the speed of light limit. Rain falls, then you see it, or hear the news report.
Standard causality.
Yes. But the region outside the light cone is called space-like. In this region, events aren't causally connected in the same way. Yusuf connects this space-like realm to the world of the unseen.
So outside our normal cause and effect.
That's the idea. A realm where knowledge of an event might precede its occurrence in our timeline, or where things happen instantaneously without that light speed delay. He calls it God's own world, or God's knowledge, and relates it to quantum mechanics, where things can seem instantaneous or causal from our perspective.
Because our perspective is locked inside the time-like cone.
Precisely. He stresses that no created being truly knows the unseen. It's fundamentally beyond our direct grasp.
This is getting deep into multiple dimensions. He also talks about virtual spaces in physics potentially being real.
Yes, things like the Eddington and Kruskal solutions, which arise when solving Einstein's equations for black holes.
Right.
Physicists often treat parts of these solutions as mathematical artifacts, virtual.
But Yusuf thinks they could be actual places.
He suggests they could be real spaces somewhere out there. The difference might be about continuity and coherence. Real space lets you move smoothly. Virtual space might have breaks or weird shifts.
And this relates to the black hole singularities again.
It does. Schwarzschild's solution gives two singularities. The one at the center, RE zone 0, infinite density, that's the physical one most agree on.
Right, the crushing point.
But there's also the coordinate singularity at the event horizon, RE's 2GMC2. Mathematically, it causes problems for the coordinates used.
Which physicists usually fix by changing the coordinate system, right?
Exactly. But Yusuf sees this mathematical problem point differently. He thinks it's the actual meeting point or interbreeding point between our world and the quantum world.
Wow. And the math used to fix it.
He points out that solutions like Kruskal's use logarithmic and exponential functions to smooth out that coordinate singularity. He sees the presence of those specific functions as evidence, like a mathematical signature of this interaction between different kinds of reality.
The language of the math reveals the connection between worlds, in his view.
That's his interpretation.
Yeah.
And it leads him to challenge the view of the quantum world itself.
How so? I thought the quantum world was just really, really small.
That's the standard view, yeah, because the particles have tiny masses. But Yusuf argues, what if the quantum world is actually very vast, a complete universe?
Vast. But quantum effects seem tiny to us.
The key difference, he argues, isn't size, it's how mass behaves. In his proposed quantum world, mass, no matter how large or small, does not distort space.
Ah, okay. So the defining property isn't size, it's the lack of gravitational effect.
Exactly. And if mass doesn't distort space, then Einstein's general relativity, which is all about space-time distortion, essentially fails in that realm.
And our 4D space can't contain it properly.
Right. The mass might then transition into another space, this two-dimensional space he proposes. That's his potential explanation for why quantum mechanics seems so weird and non-local to us. It's operating by different spatial rules.
And he links this weirdness to the unseen again.
He does. He notes that both the quantum world, particles popping in and out of existence, and the unseen are described as illogical or nonsensical by our everyday human standards. They share this quality of defying our intuition.
It's a really comprehensive framework he's building, and the math itself, the logs and exponentials, he sees them as the language.
Pretty much. He suggests, quite specifically, that when an exponential function shows up in an equation describing space, it signals the presence of another universe, specifically this quantum world.
Like X showing up means you're touching the quantum realm.
Something like that. And conversely, when we, from our 4D world, try to measure something in the quantum world, we end up using logarithmic functions.
Okay. Why a logarithmic?
His interpretation is that the logarithm erases many features. We only perceive the exponent, a kind of summary, losing a lot of the detail of what's actually happening in that other realm.
Which connects to quantum measurements being probabilistic.
He thinks so.
Yeah.
He links it to quantum operators, like the momentum operator.
Yeah.
They essentially give you this exponential output, but because we perceive it logarithmically, we lose information, leading to probabilities instead of definite values. He sees this information loss as a fundamental property, maybe even intended.
And his own equations use these ideas.
Apparently so. He explicitly builds on work like Kreskal's equations, which contain those exponential functions related to space, using them as a mathematical foundation for his ideas about these interconnected dimensions.
So wow, we've covered a lot. We've really dived into Ali Yusuf's theory, challenging conventional physics, our ideas of reality itself.
Yeah, we've touched on higher dimensions, speeds faster than light, looking at ancient texts in a new way, rethinking mass, space, the quantum world. It's a lot to take in.
It really is. It's a theory that kind of invites you to see the cosmos as maybe far more intricate, more interconnected than we usually think.
And maybe one where things we separate, like faith and physics, might actually have some unexpected meeting points.
Definitely food for thought. So here's something for you to ponder. If our universe, the one where mass shapes space, is just one layer, what other realities might exist with totally different rules?
And could we ever bridge that gap?
Right. Could the secret to, say, instant cosmic travel not be about bigger rockets, but about understanding dimensions we can't even perceive yet? Something to think about.
Mull that over. Consider the implications. Maybe look at the world around you for some of those dualities he talked about.
Thanks for joining us on this deep dive.